cosine x times h, which is sine x. I don't know. Those are the same thing though, right? Cosine x, sine x? There's two of them being added together. So isn't that 2 cosine x, sine x? And that's g prime. So when I come back over to this left side, I already knew I could get f prime in the very beginning, right? I was happy with f prime. G prime was the one that kind of needed some work. So I had to come over here to find my g prime. So this is actually a product rule inside of a product rule, isn't it? And we're going to have an easier way to do this later, once we get to the next section, which is called the chain rule. But I just wanted to show you how you could get a product rule inside a product rule. So let's write down our answer now. Y prime equals f prime, which is cosine x, times g, which is sine squared x, plus g prime. G prime was what? 2 cosine x sine x times sine x. Wait a minute. Isn't that second one sine and sine get sine squared again? So this is really cosine x sine squared x plus 2 cosine x sine squared x. And so I have one of them plus 2 of them, which is how many of them? 3 cosine x sine squared x. Because you look at this as having a coefficient of 1, and you're adding them, so it's like an apple plus 2 apples is 3 apples. Factor, yes. Plus the same thing. So it's kind of like if I say, what's m plus 2m, you say 3m, right? All right, I'd like for you to try one on your own. Okay, here we go. Now you'll need to know what the derivative of secant x is. And I gave you that last class. Well, I mean, it's in your notes for 2.3. It's 2.3 notes. It's the 10th formula. So I want you to find that derivative and simplify it, clean it up. Excuse me. There's other ways to do this problem, but I want you to use the product rule, okay? If you get it, let me know. I'm going to work through this. You identify your two functions, f and g. So we know it's going to be f prime g plus g prime f, which is the derivative of f was secant x tangent x times g, which is sine x, plus g prime, which is cosine x, times secant x. Everyone should have that first line. I mean, that's what we would call the raw derivative. Anyone have any questions on that part? Okay, so now it's a question of how do you get to the final answer of secant squared x. So you have to first realize that secant x is really 1 over cosine x. Tangent x is really sine x over cosine x. And then sine x is just sine x over 1. Plus cosine x over 1 times secant, which was 1 over cosine x. So over on the right side, your cosines will cancel, and you'll be left with just plus 1 there. And then on the left side, you've got sine squared x on top and cosine squared x on the bottom. But that's the same as sine x over cosine x squared plus 1. But what's sine over cosine? Tangent. And tangent squared plus 1. And tangent squared x plus 1 is secant squared x. What did I use to get that? That's one of the Pythagorean identities from pre-cal. The Pythagorean identities, remember, these are super important identities. The most important one is this one. Sine squared x plus cosine squared x equals what? 1. How many of you know that one? You should know that one, all right? How many of you knew that tangent squared x plus 1 was secant squared x? Maybe not. There's a way to get to this formula right here. Does anyone know how to get to that formula from this one? Divide on the top right one, the sine squared x plus cosine squared x equals 1. Divide everything by cosine squared x. Take this formula and divide everything by cosine squared x. Cosine squared x. Cosine squared x. And what do you get? What's this? Tangent squared x plus 1 equals, what's 1 over cosine? Secant. And there's another Pythagorean identity that you can get. You're doing the same thing, except that instead of dividing through by cosine squared x, you divide through by sine squared x. And you would get 1 plus cotangent squared x equals 1 over sine cosecant squared x. FYI, you can generate all 3 of the Pythagorean identities from knowing just that one. All right. So do we see kind of how the product rule works? Anyone have a question on product rule? You're all right? Let's do one more. I don't feel the vibe yet that y'all got it. How about y equals v squared plus 3v times v to the negative 1 plus 2v to the negative 3. Find y prime. So do we have product rule here? Yes. Here's your product, there's your f, there's your g. So y prime should be the derivative of f. Is that easy? Something you can do? How about the derivative of g? Is that going to be something you can do? Yeah, it should be. So what's f prime? 2v plus 3 times v to negative 1 plus 2v to the negative 3, right? Plus, what's g prime? Negative 1v to the negative 2. Good. Then, minus 6v to the negative 4. All times v squared plus 3v. So this was your f prime g plus g prime f right there. So this was just some power rule stuff, right? There's just power rule. Okay, let's do quotient rule now. All right? Let's do quotient rule. So this is kind of interesting. I'm not simplifying it, but you should be able to multiply that out. It would be a mess, but you would be expected to be able to do that. Yeah.
Would you rather us leave it like that, or would you want us to simplify it out?
I'll tell you. If I say find y prime and simplify, then I expect for you to multiply it all out. Yeah. If you go try and check your answers, like for your homework, if you check your answers in the back of the book, they're going to simplify it. So you want to try and get to that answer in the back of the book. All right, quotient rule. So if you have something like y equals this time f divided by g, the question becomes then, what is y prime? And you may think, oh, I just do the derivative on top and bottom. No, it's not going to work. Now, I'm going to prove this one to you, but I'm not going to prove it using the limit definition. I'm actually going to prove it a different way, and it's pretty cool, I think. So watch this. Here's my proof. Y equals f over g, right? Then doesn't that mean that gy equals f? And now take the derivative. Look at f as being a product rule of g and y. So take basically the derivative on both sides of this equation. What's the derivative of the product on the left side? What do you get? G prime y plus y prime g equals the derivative of the right is f prime, isn't it? Y'all see what I did there? Yay or nay? What was it I was trying to solve for there? What was it that I wanted? I wanted y prime, right? So I'm trying to get what this is by itself. So let's isolate that on one side of the equation. Wouldn't that turn into y prime g equals f prime minus g prime y? All I did was move the g prime y to the other side, right? What do I still need to get out of there? Divide by g. So y prime equals f prime minus g prime y all over g. But everyone, what is y? See y on the right-hand side? Not y prime, but what is y? What is y? Come back over here. It's f over g, isn't it? So watch this. Y prime equals f prime minus g prime times f over g all over g, right? Y'all still with me? I'm just going to rewrite this. This is f prime minus g prime